So section 3.8 is talking about radical functions and inverses. And I think we talked a little bit about inverses earlier in the semester, but we're going to talk about them again right here with the addition of radical functions. So functions involving roots of variables are often called radical functions. And then we want to remember that inverse functions are functions that undo each other. So the reason that we talk about this in this unit is because we've been talking about these polynomials, and they all have exponents, right? And when we see those exponents, we want to get rid of them sometimes. So we did a problem a little bit earlier tonight that looked like this. X squared, and we had done the work, and we got the 1 over on the other side. And then what did we do with this to solve that? We took the square root of both sides, okay? And we did that because this cancels out with this, right? Well, the same thing happens this way. If we have the square root of x equals 5, let's say, and I want to cancel out the radical sign, what do you think I might do? Any ideas? If this cancels out this, what do you think might cancel this one out? No, it's very tricky. It's if we square both sides, then this will cancel that out, right? See how these two, you got the square and the square root, they cancel each other out. Here you got the square root and the square, they're going to cancel each other out. And so we would get x equals 25. Now I just made up that problem, so it's not like that's one of our main problems or anything, but that's why we study these together, is because they work together to undo each other. Okay? So we've done these, but these are the same thing. All right, and we're going to look at these as we go through here tonight. So a function that passes the horizontal line test. Remember, the horizontal line test is this one. It tells you if a function is 1-to-1. Vertical line test tells you if it's a function. Horizontal line test tells you if it's a 1-to-1 function. But if it passes that horizontal line test, it will have an inverse function. Okay? So here's how we find those inverses. It's 3 steps. It's not super long. The first 2 steps are super easy. The third step is where we have to actually do some math. But the first step is, instead of f of x, we're going to write a y in place of that f of x. And that's just to make it a little bit shorter to write, and it's easier to work with that y instead of f of x. After we've done that, the whole deal with inverses is that they're going to undo each other. And what happens algebraically when you do that is the x's and y's switch around. So our next step is we interchange the x's and y's. So anywhere there was a y, we put in an x. Anywhere there was an x, we're going to replace it with a y. Those are the 2 easy steps. But once you've done those, now you've got it set up, and you're going to be able to solve the resulting equation for y, which means now you're going to get that y by itself. And once you have done that, once you've gotten the y by itself, that is the inverse of the original function. Okay? And again, remember the idea of inverses is they're functions that undo each other. So whatever the one function did, the other one is going to undo. And while we're not going to do a ton with that in this class, if you ever go on and take any more math, that'll be important when you're trying to cancel out functions. Okay? It's kind of like in math when we're solving equations and you have x plus 5, and you have to learn, well, what do I do to that plus 5 to get rid of it? You subtract 5, right? And it's kind of the same thing with functions. This is what we do. We use inverse functions to cancel those out. All right, so let's do this one. Find the inverse of f of x equals x minus 2 squared minus 3. So the first step is, yeah, you rewrite it, and you're going to write y equals x minus 2 squared minus 3. So that's step 1. I'll put a little 1 here, so remember that's step 1. What are we going to do next? Correct. Step 2, interchange the x and y. So here's what that looks like. Here's a y. We're going to replace it with an x. Here's an x. We're going to replace it with a y. And the rest of the stuff we just copy down. We don't change anything else. Just the x's and y's get swapped out for the other one. Now here's where we get to step 3. This is where we have to do all of our work. So our goal now is to get this y by itself. What would we do first to begin getting that y by itself? Yeah, we want to get rid of this 3. We want to like take off the outer layers, right? So we're going to get rid of this 3 by adding 3. That cancels, and now we're going to have x plus 3 equals y minus 2 squared. What's the next thing we need to get rid of? The squared. And we've done this before. This is not the new one. How do we get rid of the squared? Take the square root of both sides, right? It's just like that x squared equals 1. So we're going to take the square root of both sides, and that cancels that. And now we just have y minus 2 over here. And on this side, we have the square root of x plus 3. But what do we have to remember to always put in anytime we do that step? Plus or minus. So don't forget your plus or minus. And then what's the last step to get the y by itself? Add 2. And you can add it at the front or you can add it at the back. It really doesn't matter. But the 2 stays separate from that radical because the radical is like stuck inside. Remember we kind of said it was like in jail. So you can't put the 2 in the jail with the other stuff. It stays separate from it. So you could write it as 2 plus or minus square root of x plus 3, or you could write square root of plus or minus square root of x plus 3, and then outside put the plus 2 at the end. That's the same thing. Either one of those is the same thing. So then once we're done with that step, what we can say is, and I'm going to write it this way, and I'll tell you why in a second. So this would be our inverse of the original function. Now, the reason I'm not going to rewrite it as f inverse of x is because these, and they're both the same, but this is not a function. The reason it's not a function is because of plus or minus here. If you remember a function, this is way back when, but a function, for every input, you can only get one output. It's like when you scanned an item at Walmart, you should only get one price. Well, if we put in, let's just say a 1. If we put in a 1 here, 1 plus 3 is 4, and the square root of 4 is 2. But this says we could have a plus 2 or a minus 2. And so if it was a plus 2, that's 4. A minus 2 plus 2 is 0. We're getting 2 different answers, right? So this plus or minus right here tells us that this inverse is actually not a function. It is the inverse, but it's not a function inverse, or an inverse function, I should say. Okay, and sometimes they'll ask a question like that, is the inverse a function? And the answer is no, it's not a function. So I probably shouldn't, like I say, I probably shouldn't have that there. I'll probably just leave it as y equals instead. But that's the inverse of that one. Did those 3 steps make sense? Like I said, the first 2 are easy, just got to do them. And then the last one is the one that you actually have to do the math and solve. Okay, well, let's try another one. So looking at this one, same type of question, right? Find the interval. They've added one additional piece here. What they've done, now the last problem I didn't ask you about it, but it was a parabola, right? And so when you take the inverse, what we got was something that looked like this. And that's why we could see it doesn't pass the vertical line test anymore. That's why there was a plus side and a minus side. So what they've done on this one is still a parabola, but they've said we're only going to look at the positive side of this parabola. The vertex, okay, so this parabola looks like this. This one does. And it's been moved up 1 space, right? It's a U shape, but it got moved up 1 space. So it looks like this. And what they're doing right here is they're saying we're only going to look at the x values that are greater than or equal to 0. So they're ignoring that whole side. And by doing that, that makes this a 1-to-1 function then. That makes, now it passes the horizontal line test. It only touches once. Whereas normally that's not true for a parabola. So now we can do our steps and we'll actually get an inverse function. So first step is what? hopefully somebody said put in a y. I don't know if they did or not, but I heard something, so we'll just pretend that's what they said. Okay, and then what's our next step? Interchange the x's and y's. So this will be x equals y squared plus 1. This one looks easier than the last one. All right, what are we going to do next? Subtract 1. So x minus 1 equals y squared. Then what? Take the square root of both sides. Now and that will cancel. Now normally we put in this plus or minus, but look at what happens. Since we limit ourselves to only the positive side for the x's, when you do this work and you get the outputs are now only going to be the positive values. So what happens is you get just this positive half. The inverse always looks like a reflection over that line. Not that you really need to know that, but it's always a reflection over the y equals x line. But you only have the positive side, then you don't have to put the plus or minus on it because of this. Okay, it's only because that limitation was there. I'll tell you, I think I can't remember if I took it out, but I know that there has been in the past a question about limit the domain. How does it? I can't remember how it's worded. Something about limit the domain so that you only have the non-decreasing side. So if you remember increasing and decreasing, this side is decreasing, right? And this side is increasing because this side is going down and this side is going up from left to right. So what they've done is they have found the non-decreasing side. So you find the vertex of your parabola, and that's where you start, and then you go to the right from there. That's the non-decreasing side. So there's a question like that. I'm almost positive on your homework, so you want to keep that in mind. So if the graph gets moved left and right, you just have to find that vertex. You know, if it gets moved to the right 5 spaces, you're going to start at 5 and go to infinity. This one, they just moved it up, so they just stayed at 0 to infinity. So make sure you're paying attention to that. Okay, so f inverse of x, square root of x minus 1. Any questions on that one? So these two examples were cases where the function was not one-to-one to begin with. So we might not limit it, or in this case, we did limit it so that it was one-to-one. So let's find the inverse of this one. So this one is related to one of our toolkit functions. If we look at this part, it's related to this function right here. Anybody remember what that function looks like if you're thinking back to those toolkit functions? Yes. Yeah, it's not really an S, but that's how I described it. It's kind of like an S curve. If you're thinking about like on a road, an S curve, right? It looks like that. What does the 5 do to that when you put it in the front and multiply it? Anybody remember from the transformations? It stretches it. Actually, let me go back one step. Is this a one-to-one function right now? Does it pass the horizontal line test? Yeah, it only touches once for every horizontal line. If we stretch it vertically, will it still pass that horizontal line test? Yeah. And then what does this one do? Actually, it's separate from the x's, so it's going to move it up 1. Will it still, if we move it up 1, will it still pass the horizontal line test? Yeah, so this one's one-to-one. We don't have to worry about limiting it in any way. And so we can just do the work of finding the inverse. So what are we going to do first? Put the y in. Yep. Yeah, when you sit back that far, then I can't hear you very well. So you got to help me out. Okay, after we put the y in, then what do we do? Interchange the x's and y's. So x equals 5y cubed plus 1. Now we've got to do the work, right? Get the y by itself. What are we going to do first? Minus 1 on both sides. That's exactly right. So x minus 1, and we still have the 5y cubed here because that cancels out. What will we do after that? Yeah, you've got to get rid of the 5 first because the 3 only applies to the y. So we've got to get rid of the 5 by division. So divide by 5 here, divide by 5 here. x minus 1 over 5 equals y cubed. And now how do we get rid of that cube? Take the cube root of both sides. The interesting thing is, and you may or may not remember this from earlier, but when you take the cube root of both sides of an equation, since it's an odd index, you don't need the plus or minus. Okay? So our answer here would be f inverse of x equals the cube root of x minus 1 over 5. And that is our answer. Make steps for inverses pretty much all the time. Which one of our toolkit functions have an inverse without restricting their domain? So remember, we could take the parabola shape and cut it and restrict the domain and make it 1-to-1. But the question here is which one of the toolkit functions have an inverse without doing that? So we're going to run through them and take a look and see which ones do. So how about the constant function? Does that, what did I say? Does it have an inverse? And really, if it has an inverse, it's 1-to-1, right? So we're kind of asking the same question there. But is this one 1-to-1? Will it have an inverse? This one's kind of a tricky one, even though it shouldn't be. It looks so simple, but this one is not 1-to-1 because a horizontal line would touch this more than once, right? Because it is a horizontal line. So this one is not 1-to-1. It will not have an inverse. How about this one? I saw this. He just didn't bring it back up. He's correct. This one will have an inverse. This one passes the horizontal line test. It's 1-to-1, so it does have an inverse. Okay, how about this one? Absolute value function. No, why not? If I make a horizontal line, will it touch it more than once? Yes. So if it touches more than once, it's not 1-to-1, and so it will not have an inverse unless we adjust it some way, right? How about the quadratic? We did a lot of these, so no, we know this one's not 1-to-1 already. How about the cubic? We did one like that. That one is 1-to-1, right? Any horizontal line that you draw will only touch it one time. And so that means it's 1-to-1. And if it's 1-to-1, it will have an inverse. How about the reciprocal function? Yeah, the horizontal line test, it would touch it everything exactly one time. Interesting thing about this one, I'll maybe come back to it in a second, depending on how much time we have. But let's take a look at this one. How about this one? Reciprocal squared function. Is this one 1-to-1? Will it have an inverse? Okay, now I've got conflicting opinions. Who's right?
They're not the same. They're not attached together.
They're not attached together, but remember what the horizontal line test says. If I draw a horizontal line, would it touch more than once? It will touch more than once, won't it? Okay. And so what does that mean? It's not 1-to-1, and so it won't have an inverse unless we limit it. I could get rid of one side, and then it would be fine. But as it is, it does not have an inverse. How about this one? The square root function. Yeah, that's 1-to-1, right? Horizontal line test. It has an inverse. How about the cube root function? I've got a lot of heads shaking back and forth. Okay, think about our horizontal line test. Is it okay? Yeah, it only touches one time. So yes, it's 1-to-1, and yes, it does have an inverse without having to limit it in any way. And that's it. So let me go back. I do want to talk about this one because this one's kind of interesting. So this is the last thing, I promise. Then you'll get out of here. So if we do the process here, let's go through our process. Let's find the inverse of this one. We said it has one, so let's find it. What do we have to do first?
Y equals.
Correct. I was going to say, you guys all know this. We just did it a whole bunch of times. So y equals 1 over x. And then what? Interchange them. So x equals 1 over y. Now, we don't like the variable that we're trying to solve for to be in the denominator. Does anybody remember what we did when this happened to us before? It's maybe been a while. But what we do is, in order to get it out of the denominator, and we actually kind of did it to cancel out before. If we want to cancel this out from the denominator, we multiply by y. And if we multiply by y over there, it cancels, but then it's over here. Now, when we did it on that other equation, there was a 0 over here, but here there's not. So now we have y times x equals 1. How do we finish getting this y by itself? If it's y times x. I don't know who said something. I just heard something. I'm just not sure who or what. Yes, exactly. You can say it loud. I just couldn't hear you. Divide by x. Cancel. So y equals 1 over x. What do you notice about the inverse compared to the original?
Same.
Yeah, the inverse is the same as the original. Isn't that kind of weird? It's because think about taking the reciprocal of something and then taking the reciprocal again. Don't you end up back where you started? If you have 3/4, reciprocal becomes 4/3. Take the reciprocal again, it takes it back to 3/4, doesn't it? So that's kind of an interesting thing that most functions don't do this, but this is one that it is its own inverse. It's kind of weird, but it does happen sometimes. So, all right. You guys are good to go. Remember, again, test next week. Make sure you get your work done by Monday so that you can focus on reviewing for that test. I would say if you can get your work done early this week so that you can focus on your test after whenever you get your homework done, that would be the best. 3 problems from the last assignment, 5 on this one. So hopefully it doesn't take super long. I will be here at 4 for any questions that people have, and I will answer questions like normal until about 4:30-ish, 4:40-ish.